VirtualBox activated. Now I had originally created this nice little video, but it took me 20 minutes to implement it, and I thought that is terrible. That is just absolutely terrible, and I think you guys deserve a better brain dump if you guys want to get ahead in life. So that's what I'm going to do. So here's the first step. I'm going to just clear that bit. Look at that. It's not even there. There's nothing to look at. There's nothing to make. File not found. So let's start from scratch, shall we? Okay, so what are we doing today? Today we are going to implement a binary search. Why are we going to implement binary search? Well, we're going to implement a binary search to get myself reacquainted with C++, as I have been programming in slang, short for securities language. Language utilized in SecDB for the internship as working at Company Redacted. So let's get started now. So we need to look at the STL libraries we want to import to implement this solution. So let's look at what we need. We need IO stream. We need to print stuff to console, right? I should probably spell include correctly now. We need to include probably string. I don't know. I think we do. I probably shouldn't say that in an interview though. Don't say I think. That's you just don't say that in an interview. And there we go with the missing L again. We definitely need a vector because I don't like using arrays, so let's use vector. And I will use this later, not right now, but let's include algorithm. Algorithm has a sort function that you can utilize. And we're going to clarify where we're operating so we don't have to do a whole bunch of std statements. So we're going to use the namespace standard. And let's get our main loop going. And I have a shorthand function in my vim configuration, so I can just get ahead of you all. And let's just get this compiled correctly. I am all that is man, or every woman, depending on your stances, yo. So let's do this. Bam. Sticking, and it's done thinking, it done thunk, and I've done. There you go. Okay, let's look at what we're doing now. Harbi1, go, CPP. Let's get coding. So what we're going to do is implement a binary search, and let's get started with the function signature, shall we? What is a good name? Well, we're going to return a value of int, indicative of the index of a value that we look for in a sorted array or vector. So it's going to be int. Let's call it int search, and we're going to pass it via reference a vector of int. Ampersand is reference for y'all. Kids are a little slow today. Data. That's for our variable name. It's going to be called our parameter name. We're going to pass it an integer parameter for our target val, or rather target val. Sort for Valerian, House of Valerian. I actually don't watch that show anymore. I probably should pirate some of that off of YouTube. Okay, so we're going to use a helper function because when you go about doing a binary search and you do it recursively, you need to remember your post for the partition because you're given the entire vector. So the computer needs to know, okay, what part of the vector are we looking at? So we're going to have the helper function handle that, do most of the heavy lifting. So we're going to call that bin helper, as in the robot from the Venture Brothers, right? And then we're going to pass it the same data, and we're going to pass it the same val, targ val, and we're going to pass it an index of L_in for the left index and int R_in of the right index. Right-a-rooney. And let's get this sorted out one more time for test for sanity sake. We're going to pass an answer by calling bin helper. I'm going to pass it the data we want. We're going to pass it the data, that's not changing. We're going to pass it the target value, that's not changing. But we do know that in the beginning, we look at the first absolute left post for 0 for ln, and the absolute right is going to be data size -1 because it is not a zero-based function. Size refers to the absolute number, so if it's a size 2 array, you only access indexes 0 and 1, and it's going to return ANS. So let's look at this right now, right? So let's write some test vents right now. This is the main is going to be used test vents, so test 1. Let's call vector of int t1. It's going to be equal to a vector. Oh, there's my caps again. T1 dot pushback of 0, and we're doing sorted. The dog is barking in the background because somebody's opening the door and she's a little scaredy cat. Alright, cout. Standby 1. Okay, cout. We're going to call out the function bin search. As you're going to see a number, and we're going to pass it t1. And we're going to give it a target value of I don't care, because we're already hard coding a -1. Let's make that. And then what we have is an error. So this is why we do this. Our first error refers to a bracket that's just sort of hanging out there. So let's take that out of there. Execute ex1, and here it comes. So return and oh, they're slacking. A semicolon. Sí se puede, sí se puede. Alright, Vim. HarbiDr 1. Okay, so let's go ahead and start implementing it. So let's start by looking at the initial cases for the bin helper that we concern ourselves. The initial case when we look at the entire partition. So what we're going to do is we're going to look at the... First, let's talk about what a binary search is. We slow for crowd. Binary search is when you look at the middle of a partition for a value, and if it's greater than what the actual value you want to find, then you know that the answer is in the lower partition, and vice the upper partition. So first, we need to find that middle value. So let's go. First, find the middle index. Int mid ind is going to equal the middle of rn ln. So go rn minus ln divided by 2, but then you need to offset it by whatever our left end is. Because, I mean, yeah, sure, you don't need to offset in the beginning, but, I mean, what happens when you're in the upper partition and then you need to do a second iteration, then your left index is no longer 0, your left index is mid value plus 1, or mid index plus 1. So that's there for that case, right? So now let's get the actual value. Mid val equals mid end. And now let's start the comparison. So the easy one is if we found in that first iteration, right? So if mid val is going to be equal to our target val, then you just return the index, mid index that is. However, that's not always going to be the case. So if mid val is greater than target val, that means we know it's in the lower partition because target val is less than mid val. I can't type. So let's fix that. So then we just make a recursive call, nothing fancy, just go bin helper. So let's look at our parameters that we're going to send. We're going to send it the same data structure, right? We don't need to change that. We're going to send the same target value, right? We don't need to change that. But our left index, do we need to change that? No, because we're looking at our lower partition, so our right partition is going to be the one that changes. So let's keep rn, but our end is going to be equal to mid index minus 1. So we know mid index does not have 1, so let's just move the post over 1. And then vice for the other situation. We don't even need to put anything else. Let's just return bin helper data tog val. So ln is going to be it's just the inverse of what we were doing before. It's going to be mid in plus 1, and rn is going to remain the same. And now we says we're almost done. We just need to know that terminating clause, that clause where we say, okay, this value is even in our vector. So when do we know that's going to be the case? Well, I'm just going to tell you right now. It's when rn minus ln is less than 0, and we're just going to return like we a good developer would do. -1 when we know that our vector is going to only contain values of the positive all real number range. If it's not, then we need to find another solution that has a different return value. But the -1 signifies is our value does not exist in this vector. Okay, so with that out of the way, let's think about what I just made in the if statement clause. Rn minus Ln is less than 0. So let's consider the furthest at which we will recursively call this function. It's going to be when one of the endposts, either the far left or the far right, is our target value. So let's pretend our 0 is going to be our left index, as far as the value, not the index. And that's our target value. So if that's the case, you're going to look at the middle, see it's not there. Middle partition of the lower partition. See, keep on doing that iteration until to finally you get a point where rend equals ln, at which point mid n is going to equal 0, because 0 minus 0 is 0 plus 0 is 0. Mid value is going to equal that data value, then you return the middle index. So in that case where 0 equals 0 for rn and ln, then you have rn minus rn is equaling 0, and if you have it return -1 at that point, then you are not going to find your target value when your target value is one of the absolute endpost. So you just make it a left less than 0 for your decision. Because let's think about when the value is not there. If it's not there, then you're going to make rn drop by 1. ln is going to be held stationary, and then rn drop by 1 from 0 is -1. So -1 minus 0 is going to be -1, which is less than 0. So you return -1 because you have got to a point where a right index is to the left of the left index, and then it will be the inverse if you're looking at the upper partition where the value is not in the far right. So that should be it. So let's look at our test case. Let's add some more values. Let's look at adding yank lines. 4, 8. Let's look at finding 4. And that means our answer is going to be 0, 1, 2. So let's make. Let's see if we have any code bugs there. None. And it is 2. How about that? Now I'll go ahead and do more test cases, but I'll leave that for you to do. Let me just do a quick snapshot because I'm not going to upload this code for you. You should write it yourself. But I left the algorithm include there for later work. I'm going to be doing sorted calls on random numbers I throw in, so I might use an RNG, who knows. But yeah, bin helper, a whole 5 lines of code, 6 lines of code, right? Yeah, nothing too intimidating, right? Alright, leave comments if you think it was intimidating. I won't do anything new. Bye!